accelerated motion. This is very important. Like, you know, a uniformly accelerated motion is, first of all, you have to know the meaning of uniformly accelerated motion. This is motion. It's a motion with a changing speed. The speed changes, but the rate of change is constant. But constant acceleration. The change of velocity is constant, with constant acceleration. In this case, the change is what? Uniform. So the speed changes, but the rate of change is constant. Like, for example, if the car is changing speed by 2 meters per second every second. So in this case, we will have equations that helps us to solve different physics problems in which the value of acceleration is constant. So we use these all equations of uniformly accelerated motion if the value of acceleration remains constant. If it is motion with a constant acceleration. So let's derive the equations. Let's derive the equations of uniformly accelerated motion. Let's start with the first equation. Our first equation is, we know that acceleration is defined as the difference between final velocity and the initial velocity divided by time. We know that acceleration is the rate of change of velocity. That is the final velocity minus initial velocity divided by time t. So acceleration is the rate of change of velocity. That's v final minus v initial divided by time. This is equation number 1. The second equation is, let's make t, or here I want to make, we know that a is v final minus initial divided by time. So just cross multiplying this is over 1, and cross multiplying this, final velocity minus initial velocity will be a multiplied by t. So taking this to the right, the final velocity is now initial velocity plus acceleration multiplied by time. So if you are asked to find the final velocity, this is equal to initial velocity plus acceleration multiplied by time. This is our second equation. The other equation is, take this one, take this as it is. So we'll cross multiplying, a multiplied by t will be 80 is equal to v minus u, and I want to make t the subject of the formula, so that I will divide this by a, divide this also by a, so that a will cancel by a. Then finally I will have t, which is equal to final velocity minus initial velocity divided by a. This is our third equation. Our third equation is time is defined, is given by final velocity minus initial velocity divided by a. That's t. So this is our third equation. The fourth equation is, we know that the average velocity of an object, like for example, if the object has two velocities, that's u initial velocity and final velocity v. So the average speed or average velocity is defined as, the sum of these two velocities, that's v final plus v initial speed divided by 2. So when you say average, we mean that the sum of these two velocities divided by 2. So average means the sum of these two velocities and divided by 2. So the average velocity of these two velocities, initial and final, is the sum of these two velocities divided by 2. Fifth equation is, we know that speed is defined as the rate of distance traveled. So this is a formula that we use for uniform motion. This is a case where we use this formula if the motion is uniform motion, means motion with constant speed. What about if the motion is non-uniform? So we use here average velocity. So because we have two velocities, for non-uniform motion we use this formula for uniform motion, whereas if the motion is non-uniform motion we use the formula average speed is equal to total distance divided by total time. So if you want to make S the subject of the formula, the total distance traveled by an object is defined as average speed multiplied by t. Now this I can rewrite this as average speed is, I can use here as average speed is defined as initial speed plus final speed divided by 2 multiplied by t. That's the formula. This is our fifth equation. The distance for a non-uniform motion is calculated by the sum of initial speed and final speed divided by 2 multiplied by t. This is for non-uniform motion, but we use this formula for a uniform motion. The speed is defined as s over t, and if you want to make s the distance the subject of the formula, then s is given by v multiplied by t. In this case, because I'm using v, but this is the speed, because the speed is constant, it remains the same throughout the motion, it doesn't change through time. So I will use the formula s is equal to v times t, provided that the motion is uniform motion. Whereas if the motion is non-uniform motion, I will take the average of these two speeds, that is average speed times t. The next equations, the other equations are, I know that sixth equation is, I know that distance is defined as, this is defined as the average speed, that's final speed plus initial speed divided by 2 multiplied by t. Now from our equation, previous equation, we know that the final velocity is given by, this is defined as initial velocity plus acceleration multiplied by t. Now I want to substitute this velocity in this place. I'm going to use it here. So this will be reduced to, now this is now the same as final velocity. I can use this, that is initial velocity plus acceleration multiplied by t, plus I have here u multiplied by t divided by 2. Now I can rewrite this as, this is s, so I can add u plus u, that's 2u, 2 multiplied by initial speed multiplied by plus 80 divided by 2 multiplied by t. Now this is the same as s is equal to, now I can just multiply I can multiply t for all. It will be 2 ut over 2, because from mathematics background I know that a plus b divided by 2, I can write this as, this is the same as a over 2 plus b over 2. This is from the property of fraction, addition of two fractions. Because they are like fractions, I will take one of the denominator and add the numerators. That's what I'm doing here. 2u multiplied by t is 2ut, and I have is 2, plus 80 times t is 80 square divided by 2. That's what I'm doing. I just distribute t throughout the expressions inside and divide both sides by 2. And I'm just splitting these two denominators. Just I separate them. So here I will have now the total distance traveled is now, I can simplify, I can cancel out these two by these two. Then I will have initial speed multiplied by t plus 80 square. I can write this as 80 square over 2. This is the same as, I can write this as 1 over 2. They are the same, 80 square. So I can write this as ut plus half a t square. This is our next equation, this is the other equation. So the distance traveled by an object can be calculated as, or by initial speed multiplied by t plus half a t square, or 80 square over 2. You can write as 80 square over 2. This is our sixth equation. The last equation is seventh equation. I'm going to use this formula, take this, Let's start with this. The total distance traveled is now final velocity plus initial velocity divided by 2 multiplied by t. Now I know from the previous equation, I know that t is defined as, t is given by final velocity minus initial velocity divided by a. So I want to substitute this here. So this will be now, S is now given by V plus U divided by 2 multiplied by T. T is final velocity minus initial velocity divided by A. Now, from our mathematics background, we know that if we have A plus B multiplied by A minus B, like the same expressions except that one is plus and the other is minus. So this is the same as, this is called the difference of two squares. This is the same as A square minus B square. Same way here, V plus U multiplied by V minus U can be written as the final speed square minus initial speed square. So this case I can write this as S, because I will multiply the numerators, that is V plus U multiplied by V minus U divided by 2 times A to A. Now this is the same as, I can write this as S is equal to V square minus U square, that's the difference of two squares, divided by 2A. So now this is the same as, I'm using this property. This is called the difference of two squares, the difference between two squares, the difference of two squares. So V square, the first square minus the second square. So I want to cross multiply. So this is over 1, so cross multiply. So final speed square minus initial speed square is equal to 2 times A times S. Cross multiply now. Just multiply this by this. So it will be 2AS. Now let's make V, the final velocity, the subject of the formula. Now I want to make the final velocity of this object the subject of the formula. That is V square is equal to, when I take this to the right, it will be positive, that's U square plus 2 times A times S. So this is our seventh equation. So these are the 7 equations of uniformly accelerated motion. Now let me just write them here shortly. I just want you to write them, the 7 equations, in a short way, shortly. That is, the first equation is summary. I want to summarize the equations of uniformly accelerated motion. The first equation is, acceleration can be defined as final velocity minus initial velocity divided by time. Second, the final velocity is defined as initial velocity plus acceleration multiplied by time. The third equation is, T is calculated by V minus U divided by A. 4, distance is defined as, let's start with average speed before that. The average speed of an object is defined as, average velocity or speed is defined as, or given by the formula, final velocity plus initial velocity divided by 2. Average means, like for example, if you have n numbers, like any numbers, if you are asked to find the average of these numbers, we mean that we add all the numbers and divide by the number of the addends. If the numbers are 5, we divide by 5. If the numbers are 10, we divide by 10. If the numbers are 2, we add the two numbers and divide the answer by 2. So the average velocity of an object is defined as final velocity plus initial velocity divided by 2. First one is distance traveled by an object which is in non-uniform motion is given by initial speed plus final speed divided by 2 multiplied by t. This is for non-uniform motion. But if the motion is uniform motion, distance is simply given by v multiplied by t. This is if the speed is constant. If the speed is constant, or if the motion is uniform motion. So, but for non-uniform motion, we have two kinds of speeds. Then the total distance will be the average of these two speeds multiplied by time. That's how we find. The sixth one is equation number 6 is the total distance traveled by an object can be calculated by initial speed multiplied by t plus 1 over 2 a t square. So initial speed multiplied by time plus half a t square is a formula that helps us to find the total distance traveled by an object which is in a uniformly accelerated motion. The seventh one is, the seventh equation is final speed square is equal to initial speed square plus 2 multiplied by acceleration multiplied by the total distance traveled. So these are called equations of, all these equations are called, equations of uniformly accelerated motion. We call this equations of uniformly accelerated motion. We use this formula provided that the value of acceleration remains constant. Otherwise, if the acceleration changes through time, we cannot use this formula anymore. We use this formula if and only if the value of acceleration is the same. And which formula to use depends upon the given quantity. It depends upon, what matters is depends upon the given quantities, like the given physical quantities. So which formula to use depends upon what are the given quantities. So we can just, what we have to do is we have to remember all this formula and look at the given quantities, then just continue solving the required one. So here what you have to know is, first we use this formula if and only if the value of acceleration remains constant. One. Second, which formula to use depends upon the given quantities. That's all. So these equations are called equations of uniformly accelerated. So I put them right here so that you can clearly memorize them easily. We can just memorize them in a simple way. So here is the derivation, the way how we get the formula, and this is the shorthand representation of the equations of uniformly accelerated motion. Now let's see examples.